So we're now going to go ahead and talk about the third part of our image crawler case study, where we're going to demonstrate how the stream of futures collector class is designed and implemented. And its role is to basically take a stream of completable futures and return a single completable future that's triggered when all the other completable futures have themselves completed. So we're now back in my IntelliJ project, where we're going to take a look at the place where crawl links in page calls the collect method to take the stream of completable futures that have been generated by recursive calls to count images async, and then it's going to consolidate them all together into a single completable future by using the FuturesCoillectorIntStream collector, which is a little redundant. But let's take a look at this. So here's the factory method that gets called. It's called toFuture, and as you can see, it returns a new FuturesCoillectorIntStream object. And FuturesCoillectorIntStream is a class that implements the collector interface, and as a consequence, it has to fill out 3 generic parameters. One parameter is the type of the stream that we're going to be collecting, and it's going to be a completable future to integer. We then also have what's called the accumulator, which in this case is the mutable result container that's going to store the stream elements in a list. And then the final parameter here is the return result, which is a completable future to an int stream. So that's what's going to get returned from the finisher method, as we'll see here shortly. So let's go ahead and take a look at the various methods in this class. You can see they're all essentially factory methods that are used by the Java Streams framework. And the first one is called supplier, and that is a function. That is a supplier that returns a constructor reference that, when called by the framework, will make the mutable result container object. And in this case, we have a constructor reference to an array list. So we'll end up making an array list to hold the elements that were streamed to us by the map method before collect was called. So that's what gets returned from supplier. Let's now go take a look at accumulator. And let's see, it's kind of a long method. So we'll put a line break there to see it easier. The accumulator returns a by consumer that will take the next element in the stream and fold it in with our mutable result container. And the way we do that is just by using the list add method. So that's what gets returned from accumulator. The next method here is called the combiner. And this is used were we to have a parallel stream. We do not have a parallel stream, so this method will not be invoked, but we still need to provide it because the streams framework expects it to be there. And what it does is it takes 2 sub results that would occur if we were doing parallel streams, and it concatenates one at the end of the other. And then it returns the first one. So that's how the combiner method works. And then the most interesting method here of all is the finisher method. And you can see finisher, which I should also probably line break a little bit because it's too long. Finisher is going to perform the final transformation, and it's going to essentially take a list of completable futures and then return a completable future to an int stream. And it does this by using the magic of the completable future all of arbitrary arity method. And here's what we do. We use completable future all of, which can take a variable number of parameters. And we get that variable number of parameters by taking the futures list, that was that mutable result container we created with our supplier. And that's passed in here to this method. And if you want to see what it actually looks like, we can replace this with an anonymous class, and you can see what it actually would look like if we didn't use wonderful modern Java functional features. So what happens here is the apply method in the anonymous class is passed a list of completable futures. And so that's what we would get if we didn't use the Java 8 features, the modern Java features. So futures is a list. We convert the list into an array, telling it to use the type that's in the completable future sub-0 element. So it's just making a completable future. So we essentially have ourselves this array of completable futures. And as you may recall from the discussions of all of, that returns a single completable future that, when triggered, indicates that all the other completable futures have finished processing, either successfully or unsuccessfully. Assuming things succeed, the then apply completion stage method will get called back. And what we do then is we take that futures list that was passed here to the finisher method. And then we go ahead and turn that futures list into a stream, which will be a stream of completable futures of type integer. And then we use the map to int method to convert that stream of completable futures to integers into a stream of integers, or an int string. So map to int returns an int string, and you can tell that because that's what the return type is. And then apply, of course, will wrap that int stream in a completable future, and that completable future can then be used back over here in order to wait for all the other things to finish. And when all the other things finish, the then apply method gets called here, and we go ahead and compute the sum of the elements to get that result. So that's the most interesting method here in the FuturesCoillectorIntStream. And then finally, here's just the characteristics method, which, as you can see, just returns a singleton indicating we don't care what the order is because this is all happening asynchronously. So what's the point? Ordering is not as important in this particular case. So that's essentially the walkthrough of the FuturesCoillectorIntStream class. It's a very useful pattern. I use this over and over again through a lot of the things I do. And if you want to know more about this, then take a look at this particular link, which is where I initially learned about this many years ago by a presentation from a guy named Tomas Nurkowitz, and he does a wonderful job of kind of explaining all this stuff. And then I kind of got inspired and sort of built all these wrappers that make it much easier to work with completable futures in the context of Java streams. So that's the end of that final part of the 3-part lesson on the image counter case study illustrating Java completable futures.